Alright, so we are looking at hyperbolas again for day 2. This is going to be partly writing the equations and again graphing as well. So on example 1, I want to find the standard form of the equation of the hyperbola with the given characteristics and the center at the origin. So this origin tells you automatically that my HK is going to be 0, 0. So when we write our equations, we're just going to have x squared and y squared in the numerators. If I look at what they give me on example 1, they tell me that the vertices are at plus or minus 3, 0, and the foci are at plus or minus 5, 0. So if I were to graph that, that would be left and right, 3 for the vertices. So this means that this is going to be a horizontal hyperbola. So if it's horizontal, remember from yesterday, your x value will occur first. So I know I'm going to have x squared over something minus y squared over something equals 1. Now, your vertices, going to your formula chart, they are, if we look at the horizontal, they're your a values. So we have a, and they also give me the foci, which would be your c values. So I need to figure out my b value for my equation to plug in. So we're going to be using the c squared equals a squared plus b squared. So I know that a is 3, and I know that c is 5. So if I have a squared plus b squared equals c squared, I can figure out what b squared is. So I'm going to take 9 and subtract from 25, and when I do that, I get 16. So b squared is 16. Remember that on hyperbolas, no matter if it's horizontal or vertical, your a is under whatever comes first. So if I square 3, I'm going to have 9. If b squared is already 16, so I'm going to have that. So my b would have been 4 if we went ahead and kept solving for that. Other main thing is, for today, make sure that you are always having a subtraction in between your x squared and y squared. Otherwise, it would not be a hyperbola. All right, let's look at example 2 now. So example 2 gives me vertices at 0, plus or minus 1, and an asymptote at plus or minus 1 over 7x. So vertices, if I were to graph that, would be up and down 1. So I know that this would be a vertical hyperbola. And then your asymptotes, if we go to that formula chart on vertical, I have plus or minus a over b, and then my h and k would have been 0, 0, because they told me the center's at the origin. So this right here is plus or minus a over b, like we just said, x. So automatically I know what my a is. It's 1, because that's the numerator, and my b is 7. Okay, because this is a vertical hyperbola, that means my y value will come first. Okay, once you have that, you'll then place the a value underneath the y. So 1 squared is 1. And your b value under the x. 7 squared is 49. So there's our equation for that hyperbola. All right. Example 3, it says, find the standard form of the equation of the hyperbola with the given characteristics. So this is similar to example 1 and 2, however, the center is not at the origin this time. So I have to figure out where the center is. So we're going to use the information they give us to help us figure that out. If we plot the vertices, I have negative 1, 2, and I have 3, 2. Okay, your center is always directly in the middle of your vertices. So if I go halfway there, this distance right here is 4, so halfway between 4 would be 2. So my center would be at 1, 2. Okay, this distance from the center to that is going to be your A value. So your A value is 2. Okay, they also give me the foci. So if I graph the foci with a different color, I'm going to be at -3, 2, and then 5, 2. The distance from the center to that foci would be your C value. So my C value would be 1, 2, 3, 4. In order for us to write the equation, we need to know the B value as well. So the other thing that we need to know is that this is going to be a horizontal hyperbola because it's going to the left and to the right. So that means my x will come first minus my y. So remember on that equation, if we go back to that, we have x minus h squared over a squared minus y minus k squared over b squared equals 1. Your center is the hk. So if I have x minus 1 squared, I'm going to have y minus 2 squared, and then I have to figure out what my a and b values are. I already know a. It's 2. So 2 squared is 4. Now I just have to figure out, there should have been equals 1 there. I'm going to get some white to make that look better. All right, so we're going to use the a squared plus b squared equals c squared to figure out our b squared. So I know a squared would be 2 squared, b squared is what we're finding, and c squared would be 4 squared. So from here, I'm going to have b squared equals, this is 16. If I were to subtract 4, I get 12. So b squared is 12. So that would go underneath your y. So this tells me that I have that hyperbola with a center of 1, 2, and then a horizontal distance 2 away from the center to give me my vertices, and I would go vertically the square root of 12 to help me create the box that I need. All right, on the next 2 examples, we're writing in standard form. So this is where you want to complete the square. On the first example, we actually don't have to because there are no other terms besides the x squared and y squared terms. So there's not an x and there's not a y. So first thing I'm going to do is make it equal 400. And then I'm going to make it equal 1, which is our goal when we do it to standard form. So to make it equal 1, we're going to be dividing by 400. So I'm going to take each piece divided by 400. When I divide those, I'm going to type that in my calculator. And if you have a regular calculator, you can put it in as a fraction doing alpha y equals. This one doesn't do that, so I'm going to do normal fraction like this. I get 16 over 400. I can change it back into a fraction by doing math, enter, enter. And that gives me 1/25. So what that really means is that this is y squared over 25 when I simplify. Minus, if I do the same thing with the 25 over 400, math, enter, enter, I get 1/16. So that's going to give me x squared over 16 equals 1. So this should look like your standard form. Okay, if I were to talk about what kind of hyperbola it would be vertical because y is first. Your vertices would be up 5, down 5 from the center, and so forth. All right, example 5, we're going to have to do some complete the square, rearranging, group your x's together, group your y's together, move your constant to the right. So if I group my x's together, I'm going to have x squared minus 6x minus y squared plus 16y equals 119. I don't have to factor anything out of the x. On this one, I need to factor out the negative, so I'm going to have negative y squared minus 16y equals 119. Okay, from here, we're going to complete our square. So I'm going to take half of my b, so in this case, half of negative 6, and square. So half of negative 6 is negative 3. Negative 3 squared is positive 9. So remember, what we add to the left, we also have to add to the right. Same thing with the second piece. I'm going to take half of negative 16 and square it. So half of negative 16 is negative 8. Negative 8 squared is 64. So on this one, we have to add negative, because of the negative that we took out, 64. So let's factor this. I'm going to have x minus 3 squared minus y minus 8 squared equals, if we do this math, 119 plus 9 minus 64, I get 64. So it equals 64. For us to be in standard form, we're dividing each of these things by 64. So I'm going to divide each piece by 64 so that it will equal 1. And my final answer would be all of this equals 1. However, I ran out of room. So let's just mark this out and put 1. If there were coefficients in front of the x minus 3 or the y minus 8, then I would need to simplify the fractions like we did in example 4. So this hyperbola would be a horizontal because x is first, and your vertices would be left and right 8 from the center. All right, final example. Write in standard form, then identify the center, vertices, foci, and asymptotes of each. Then sketch a graph. So we did all of this yesterday except for the write in standard form. So I'm going to be taking my equation. I'm going to go down here where I have a little more room. And I'm going to group my x squareds or my x's together. And move my constant to the right. So I have negative 4x squared plus 8x plus y squared minus 20y equals 4. When we factor out the coefficient on the x, I need to factor out negative 4. When I do that, I have x squared minus 2x. And then I don't need to factor anything out of the y's because your coefficient is 1, which is what we want. So now let's complete the square. So if I take half of negative 2 would be negative 1, and negative 1 squared is 1. So I'm going to add 1. Okay, that means I'm over here adding 4 times negative 1. Nope, other way around. It would be times negative 4 times 1. So adding negative 4 times 1. So your coefficient was negative 4 times 1. And then on the y, half of negative 20 is negative 10. Squared would be 100. So I'm going to add 100. I meant to do that in the other color. Oh well. So I have negative 4 x minus 1 squared plus y minus 10 squared equals 4 minus 4 is 0 plus 100. Okay, like last time, we want to equal at 1, so I'm going to divide every piece by 100. Okay, and if you notice, the negative is in front, but all of our formulas have the negative in between our two equations. So what I'm going to do is, because it's subtraction, I'm just going to move that to the middle. So when I rewrite this, I'm going to write the y first over 100 minus x minus 1 squared over, if I were to simplify negative 4 over 100, that would be 1/25 equals 1. So once we have it in this standard form, we're going to look at all of the pieces to help us graph. So first thing to notice is that it is going to be vertical, and the reason it'll be vertical is because the y comes first, or the x is negative. So center, remember if it's in this order, your center is still h is with x, k is with y, so my center is going to be positive 1, positive 10. Okay, we have this big graph because we're using some fairly large numbers. So I'm just going to choose a line to make, oh, that was not straight, my axes. I made it further down than up because we're going to be going up and down 10 from 10. So I want to make sure I have enough room. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my center. On here, A is 10, B is 5. So the direction we're going to be going 10 is up and down because it's under the y. So from the center, I'm going to be going up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which would be at 1, 20, and down 10, which would be at 1, 0. Okay, then I need the other points to help me draw my rectangle. So I'm going to be going left 5 and right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have the midpoints of my rectangle, which will also allow me to draw my asymptotes, because remember they go through the diagonals of your rectangle. And this will allow you to draw your pieces going up and down through the vertices, because it was a vertical hyperbola. Okay, the other part of this are the asymptotes and the foci. So asymptotes, you can find your slope would be up 10 over 5, which you could simplify to be 2, times x minus h plus k. So again, if you don't remember that formula, it is on your formula chart. And then the foci we can get by doing a squared plus b squared equals c squared. So a squared is 100, b squared is 25, so that's 125. If we simplify that, because we're taking the square root, that would be the square root of 25 times 5, which would be 5 root 5. So which direction will we be going that amount? We would be going up and down that amount. So 5 square root of 5 is approximately 11.18 if I type it in my calculator. So that would be right after each of these vertices. So if I look, my x value does not change. It's my y value that's changing. So I'm going to have 10 plus or minus the 5 square root of 5. All right, so hopefully all of this is not looking too crazy. Please try your best with your A10. If you have questions, I'll be back tomorrow to answer them.